Hello everyone, this is Somendra from Tutela. Today I'm going to cover a topic which is a source of confusion for many students who look at this topic for the first time. The name of the topic is, the name of the topic is logarithms, or you can call it logs. Now, logs is a source of confusion for many students because we are not taught logs right from the beginning of our school. So first thing about logs that we need to know is logs are inverses of exponents. That means they do exactly opposite to what exponents do. A log will always have two parts of it, log, and in a subscript you have a base, and then you have a number given here which is actually an input value for which you are finding the log. The result that it gives is the exponent value of something, which is exactly opposite to what happens if you have, I'll make it easier for you to look at. If I have base of A and input value is C, then you get a B. Then in what we have been doing, we'll say that we have A raised to power B is equal to C. So what we have here in exponent is a base, an exponent, and the result. But when we use logs, the exponent is unknown, but you know the base as well as the input value. I'll take an example. 2 raised to power 5 gives you, if you do the math, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So you have 32 as the result. But what to do if 2 raised to power x is given equal to 32? Now, the exponent is unknown, so you'll use logs for it. So log, you'll write this as log of base is base 2. Input value is the result that we got in exponent, so 32. The moment you input this in your calculator, you'll quickly get the result as 5. So logs are inverses of exponent in a way that exponent give you the result when base and exponent value is known, whereas logs give you the exponent value if you have the base and the result given to you. You can remember this as ABC here. ABC becomes ACB. Now this is a rule that has been working for me for ages, so definitely it'll help you as well. Now I'll make you go over some exponent rules and then I'll try to connect them with the log rules that are in place. So let's just make the scratch work ready. Exponents. First basic rule, when you have same bases multiplied to each other, the respective exponents get added. When you have same bases dividing each other, the respective exponents get subtracted. When you have exponents in parentheses, the respective exponents get multiplied. Then let's talk about some more rules. For example, if you have a base raised with a negative power, what you have to do is you have to just do the reciprocal of the base and then raise it with the positive power of that. Another example is when you have, say, a over b raised to power minus c. Now, because there is a minus exponent, you have to reciprocal the whole thing and then raise it with power c. Then more rules coming. Oh, sorry for that. So fifth rule I'll say is when you have a fractional power, something that's not very common, people usually get confused with this one. When you have a fractional power, what you have to do is the numerator of the fraction acts as a normal exponent, whereas the denominator acts as the power of the radical. So this can be written like this. Then there are some special cases. For example, if an exponent is raised with the power of 0, the result is 1. And that's pretty much it. Okay, one more thing that I want you to know. If you have a non-zero base, say 2 raised to power x, it will always be positive. It will not be 0, it will not be negative, because the base is positive. There is no exponent that can change its sign to negative, and there is no exponent that will make it 0. All these things are the ones that you probably already know. Now I'll make you good with the logs counterparts as well. Rule number 1, which is exactly opposite to rule number 1 of exponents. It says that if you have two logs of the same base getting added to each other, then you actually have to add the input values to get the same result. If you pay attention, it's exactly opposite to what we were doing here. The logs give you the exponents, and when you add two exponents, definitely there must have been, we might have to remove that portion. Yeah, now we'll do the logs rules, which will be in some way related to the exponent counterparts of them. Rule number 1, when two logs of same base are added with each other, then that means that you'll get the same result by multiplying the input values of two different logs, which is exactly opposite to what we did in the first rule of exponents, where the exponent got added when the bases were multiplied. Similar to this, you have rule number 2 that says that when two logs of same bases get multiplied, oh, not multiplied, subtracted, then basically you'll get the same result by dividing the input values. There are many different rules. For example, log, irrespective of the base, of an input value raised with a power already can be written as this. So log of x raised to power a is actually a log x. Next we have, say, log of, you can say log of base a with a. If you look at this statement, it's as if you're asking the log, what power of a is a? So you got that right, the result is 1. Log of any base of result 1 will be 0. This is exactly opposite to this rule here. It means that if with any base the result is 1, then definitely the exponent must have been 0. Sometimes what happens is you have an equation which looks like, okay, I'll take that as an example. If you have a question that gives you an equation that looks like this: log base ax plus log base by. Now you can't do anything with this. You can't write this as log a b x y, or for that matter anything. No. Why? Because the bases are different. You have got different bases. To make this work out, your job is you have to make the same base for both of them. So a base change formula is there that I'm going to cover now. Base change formula says that when you want to change base of this thing to whatever base that you want, say I just want to change it to base 10, log base 10, which is just written like this. I want you to change log base a of x to log base 10. So what I'll do is I'll get log of x done divided by log of a, which means for this particular question what I can do is I can just write log base b of x divided by log base b of a plus whatever was already given. Now you can deal with it since you have all the bases same. The moment you face any doubt, your job is to put any of the query in the comment section. Now let's have the corollary of this rule. That rule says that if you have a non-zero base, you can't have a result of 0. That'll mean if you have a non-zero base of 0, then what will be the result? You'll say that it's not defined. Why? The reason is if you have base of 2 and the result is 0, how is that even possible? So you'll say not defined. That's our last rule for the class. Now that we have gone through all these rules, I have some examples, some questions that we can do, and hence we can practice the rules that we have learned. Now, question number 1 says that log base 5 of x is equal to 2. They're asking you what's the value of x. Now, we'll read this again. It's as if the question is saying that what power of 5 the question is saying that 5 raised to power 2 is going to give you what result. So I can change this as 5 raised to power 5 raised to power 2 is equal to x. What I'm using here is ABC will mean the same thing as log base AC of B. Now that I have A as 5 here and B as 2, I can write this in exponent form as 5 raised to power 2 is equal to x. So x will become 25. So the correct answer will be D. Let's move on to some other question. I have prepared some questions for you already. Again, now this one says that log of base A 64 is 3. Using log ACB, then A raised to power B is equal to C is true. I'll write this whole thing as A raised to power 3 is equal to 64. Now you should know, you should be good at your cubes as well as squares if you are giving ACT. Now you can think about it, which base raised with the power of 3 gives you a 64. So your answer will be A has to be 4 for that. So the answer will be B to this. Let's see some more examples if we have those. Yep. Now this one is a little bit complicated, looks complicated at least. It says that log base x of z is r, alright, and log base x of y is s. Then what will be the value of log base x of z squared over y? This sure is complicated, but let us see how can we crack it. Let's have a look at the complicated solution that we are looking for. It is saying that you have to find the value of this. Let's think about some rules that we have done. Till now, the main rule that I can see getting implemented is I can write this thing as, oops, I'm changing too many colors. So I can write this as log base x of z squared minus log base x of y, because the rule says that log a minus log b can be written as log a over b. So it's the inverse of that I have done here. Then let us see what else can be done. Till now, if I move on, I'll say that log base x of z squared can be written as, oops, I would like to change that. Yeah, it can be written as twice of log base x of c. The rule which is getting used here is log a to the power x can be written as x log a. Now, I'll move on towards the problem. So I have to find from here, I have to find log twice of log base x of c minus log base xy. Now, if I put in the values from here to this, I'll get the result of twice of log base x of z is r, so twice of r minus log base xy, which is s. So finally, I was able to get the result for log base x of z squared over y, which is 2r minus s. So my answer will be D here. Moving on to some other question. If I have any left, yes, I have one more question left. So let's do this one now. It says that log base b of x raised to power c is equal to a. What is x in terms of other variables a, b, and c? So let's see if I can change this using some log rules. First off, I have the input value raised to the power of c. So I can write this as c log base b of x equal to a. I have to make x the subject, so let's start stripping the left hand side of all other things. So I can divide both sides by c and I can get log base b of x equals a by c. Now, if I use a, b, c and ACB rule here, I can write this whole thing as b raised to power a by c equal to x. Bingo, we got the answer. But wait, do we have this in any of the answer choices? I don't have any of b raised to power a over c anywhere. So I'll have to simplify this a little bit. So if you look at this, it's a fractional power which can change easily to b raised to power a, and the denominator c becomes the power of the radical. So let us see if I have this in the answer choice, and yes, we do have it, c root of b raised to power a. Hence the answer will be B here. That's all from the log chapter. If you have any doubt on this, make sure to make me aware of those doubts and queries in the comment section. If you understood anything from this chapter, make sure to like, subscribe, and don't forget to tap on that bell icon so that you can get aware of every new content that I'm uploading here. Have a good day. Bye bye.